Hey, what's happening, everyone? Welcome to another episode of HPC in the Cloud. I'm Joe Schoonover from Fluid Numerics, and today we're going to be talking about how to run OpenFOAM on Google Cloud Platform. So let's just go ahead and get started. So first, you're going to want to head over to console.cloud.google.com. We're going to start by creating an auto-scaling HPC cluster, and to do that, you'll start by just going to Marketplace, hit that Products and Services menu in the top left corner of the console. Scroll down to Marketplace underneath Products, and when that loads in that search bar there, just type in Fluid Slurm GCP. Click on that top solution that we have available there. This is a CentOS 7 based HPC cluster with a Slurm job scheduler installed in it for you. Go ahead and hit launch, and then we're just going to fill out this form to deploy our cluster. Essentially, we're going to be getting what's called a controller that's going to host the Slurm job scheduler, and we're going to be getting a login node that you'll actually be able to use to access the cluster and schedule HPC workloads on demand. I'm going to go ahead and just call this cluster OpenFOAM demo, and I'm just going to let everything else be the defaults here. Just know that whatever you set here is not set in stone. You can always customize your cluster after the fact. If we go down to the compute partitions, we will do a couple of, custom settings here for our case. I want to call that first compute partition, we're going to create OpenFOAM, leave the max node count to 10, that's fine. And then for today's demonstration, you're only going to need 8 vCPUs in that compute partition. So if you click on that drop-down menu for the machine type, scroll up until you find N1 standard 8. Okay, and then change that boot disk size to 50 gigs. You will need a 50 gig boot disk so that you can actually use the OpenFOAM GCP image that we've created for you. Once you're done there, go ahead and hit deploy, and this will bring you to the deployment manager page where you can monitor the status of this deployment. And again, all we're getting out of the box is just that controller and that login node. Compute nodes will be created on the fly because this is an auto-scaling cluster as we submit jobs. While that's being created, I did just want to point out a resource that we're going to be making use of here in the next couple steps, where we have a Slurm batch file that's going to run the Naka 012 OpenFOAM example for us. If you head on over to GitHub, you can find this page underneath our Fluid Numerics organization page. The repo is called Fluid Slurm GCP Custom Image Bakery. In the root directory, we have some template files to help you get started with baking your own custom virtual machine images with Packer and Google Cloud Build. And the reason why I'm pointing this out is because this is what we actually use to create the OpenFOAM GCP image that we'll be sharing with you today. And if we click on through underneath that examples OpenFOAM directory, you'll be able to take a look at some of the resources there and kind of get familiar with how this process works. I'll give you the quick rundown here while we're waiting for that cluster to load. So we have a startup script which essentially handles the process of installing OpenFOAM and all of its dependencies. This version of the image that we've created for you uses OpenMPI 4 for MPI, and then a GCC 9 compiler. Everything else is basically pretty standard in terms of the OpenFOAM install. We're just using OpenFOAM dev, walking through the installation of its dependencies through the third-party dev repository, and then the installation of OpenFOAM. Next, we have this packer.json file, which is essentially an input file for HashiCorp's Packer command line tool that will essentially create a Google Cloud virtual machine, execute the startup script on it, and then handle tearing down that resource and snapshotting the disk to create the image. And then last thing, to tie it all together so you don't necessarily have to have Packer installed in your own system. If you can access Google Cloud, you can use Google Cloud Build. We've created a cloudbuild.yaml file for you that essentially calls out Packer to build that virtual machine image for you. Sharing this because, one, I want to show you guys how we create these images for you, and so that maybe if you have your own applications or if you want to customize your installation of OpenFOAM, you can do that yourself. Let's go check in on that console, see where we're at in terms of the installation process here. It looks like we're actually done. You can tell that because we actually now have an IP address for the controller and the login node. So what we're going to do now is hop into that controller and customize the compute partitions to use the OpenFOAM image. So to go ahead and log into that, we're going to copy that IP address, and on the top right, we're going to click Activate Cloud Shell to open up a terminal in our browser. Once this loads, there's two steps you'll probably want to take care of if you haven't done it before, if you haven't used OS Login. You're going to need to create an SSH key And then you're going to want to attach that SSH key to your Google Cloud Identity profile. So to create that SSH key in your Cloud Shell, just run SSH keygen -t RSA. Now I've already created one in my Cloud Shell, so I'm not going to run that. But if you haven't, go ahead and do that now. And then once you have that key, that should set up a key underneath in your home directory, underneath a hidden directory called .ssh. Inside of that directory is a file called id_rsa.pub. We're essentially just going to attach that file to your Cloud Identity profile so that you can just use OpenSSH to connect to that controller. So go ahead and do gcloud compute os login SSH keys, add, and then do key file as the option. And for the path, you'll put your home directory. So for me, it's home Joe, and then we'll do .ssh. Then we'll do id rsa.pub. Again, I've already attached one to my profile, so I'm not going to run it here. But if you haven't done it, go ahead and do that now. And once you're set up there, you should be able to go ahead and SSH into that controller. So to SSH, we'll just do SSH your username. Now, if you're using a Gmail account, or if you haven't configured your POSIX user ID for your G Suite or Cloud Identity account, your username will essentially be your email address. Just replace those @ symbols and dots with an underscore. Now, if you have any questions about that, feel free to post into the chat, and I'll be happy to answer those for you. All right, so I'll do SSH Joe @ and we got the controller IP address here. We're going to go ahead and hop in, and then we're going to customize this cluster to use the OpenFOAM GCP image that we've created. Okay. Now, to do the customization, we're going to be using a command line tool called Cluster Services that does require root privileges in order to use. So go ahead and run sudo su to go root. And then cluster services, we're going to type list all as the commands that go into cluster services to dump out the current cluster configuration. We're going to go ahead and write that to a file called config.yaml. Okay, let's open that up. And let's turn on numbering here. All right, so on line 1, this is like one obvious spot where you can change out the images that you're using for your compute nodes. Now, if you set that here, what's going to happen is all the compute nodes in your cluster are going to end up defaulting to using that image. So instead, what I like to do is actually, if you scroll down into the partitions and in the machines, what we're going to do is add the image key in that first machine block. Okay. And then we're going to give it what's called the self link to that image path. So if you ever use any of our images that we publish for you guys, it's always going to be, let's see, projects, fluid, cluster ops, global, images, and then we'll have the name of the image. Today we've created one for you called OpenFOAM GCP. Now, if you've created an image in your project, essentially what you'll do is just replace this fluid cluster ops with your GCP project ID if you have your compute node images hosted in your own projects. But that's essentially it. Double check, make sure that disk size is set to 50 gigs. Otherwise, you're going to have some problems launching your compute nodes. But from here, we should be good to go. So let's go ahead and update those partitions. And then once we update partitions, we're going to take care of setting up the Slurm accounting so we can actually submit jobs. So to update those partitions, you're going to run cluster services, update partitions. We're going to pass it a config file. And then we're going to run with the preview flag. Okay. I always recommend using that preview flag just so you can just double check your work before you actually commit the changes to your cluster. This is looking okay to me, so once you're happy with it on your side, remove that preview flag and run the command. This will update the partition, so now every time a machine is launched in that partition for that particular machine block, it will be using OpenFOAM GCP. Okay, so now let's take care of setting up the Slurm accounting. So the first thing we're going to do is create a template block for the Slurm accounts specification that we can append to the cluster config file that we've just created. So we'll do cluster services sample Slurm accounts, and then use the double right carets to append that to config.yaml. So let's open up that config.yaml again. Down here, let's see, what line is that? That's going to be line 44. Go ahead and cut that line and paste it down below. Okay, and then remove the square brackets that are now on line 48, and let's fill out some of the settings here. So for that allowed partition, the partition name that I've chosen is OpenFOAM. If you have a different partition name, just go ahead and set that there. Now the name of the Slurm account is really up to you. I usually like to pick something that's representative of the job function of the groups of people that are going to be using this Slurm account, or maybe if it's an NSF grant, a DOE grant, what have you. Just pick something that makes sense to group these users and to allow them to use this partition. Since we're doing OpenFOAM and this is a CFD application, I'm just going to call this CFD. And then down below, you can just provide a list of all your users. Just put their Linux username in that list. All right, and again, we're going to run back through cluster services update, and this time we're going to run update on the Slurm accounts. Okay, again, pass it that config file, and preview first. Double check your work. If you run sinfo, make sure that that partition name that shows up on sinfo matches up with the allowed partitions there. This is a common issue if you just misspell. This can cause just a little bit of frustration. Just double check that, make sure your username is spelled correctly as well. And yeah, from here you're good to go. Once you're happy, remove that preview flag and hit enter. This will set up your Slurm accounting, and so you and anyone else you added to that Slurm account should now be able to use that OpenFOAM partition to run OpenFOAM jobs. So we're essentially done here on the controller. Now what we want to do is log out and then hop in on the login node. And I'm gonna basically get you access to this OpenFOAM.slurm sample batch file that's gonna run the NACA 012 compressible, the row simple foam tutorial problem. So let's go ahead and do that. So go ahead and log out of that controller. Let's copy this login IP address from the deployment manager page. So with the SSH, your username at IP address for the login node. Go ahead and hit yes. Make sure that you are in the login node. You can see that there in the host name, you have the word login. Great. Double check that sinfo works, okay? Everything's looking good. So now what we want to do is clone that repository I shared with you before, because in that repository we've included this example Slurm batch file that will run OpenFOAM for you. So we'll just do a git clone, okay? github.com, fluid numerics, and then fluid slurm GCP, custom image bakery. .git. All right. So at this point, you should see we have a config.yaml and this fluid slurm GCP custom image bakery directory now in our home directory. From there, what we want to do is copy underneath that repository. We're going to go to examples OpenFOAM, OpenFOAM.slurm, and go ahead and copy that to your home directory. So now you should have 3 files in there. We have this OpenFOAM.slurm, which is essentially what we're going to submit to the batch scheduler, sbatch, to run OpenFOAM. Before we do that, open up that file. Double check that the Slurm account that's in this line here, it matches up with the Slurm account that you just created a couple minutes ago. Also make sure that the partition name on the right-hand side, this equal sign, matches up with the name of the partition where you now have a machine block that has the OpenFOAM GCP image. If you have all that set up, you should be ready to go. So go ahead and run sbatch OpenFOAM.slurm, and the job goes through. If you run sq, you could see that we now have job ID 2. It is running in the OpenFOAM partition, and it's now in a configuring state. It's going to run on a compute node called OpenFOAM 0. So to see what's going on there, in that products and services menu, go ahead and click on that. Let's open up Compute Engine. So I kind of want to show you what happens here when you submit a job. What it really means when this node's in a this job's in a configuring state. So essentially, when we submitted the job, the controller made a request to Google to create this node for you. You can see OpenFOAM 0 is currently being provisioned. And essentially, it's going to run through a startup process. It's going to mount the home directory and apps directory and start a Slurm daemon and then start running the job. So we'll let that spin up. This process can take anywhere from 30 seconds to 3 minutes. So while that's happening, let's look at this Slurm file so you can get a feel for how you might want to run your OpenFOAM applications. So open up that OpenFOAM.slurm. So if you're So I guess let's talk about the batch header here real quick, and then we'll get into the meat of like the actual instructions that are running inside. So at the very top, these sbatch commands essentially are ways for you to interface with Slurm to request the amount of compute cores you want to have, the amount of memory, GPUs if you're using GPUs. We've kept it pretty simple here. We're just saying, hey, I need to run 8 tasks, and I want to run 8 of those tasks on a single node, or at most I want to have 8 tasks per node. So in this case, those tasks correspond to the number of MPI ranks, as you'll see down below. And then the only other thing we specified up here is where to put standard out and standard error messages. And those are going to a file that's OpenFOAM minus the %J stands for the job ID. So for here, since our job ID is 2, we'll have our standard out, standard error messages going to openfoam2.log. Okay, so now let's get into some of the meat here. Now, if you're going to be using the OpenFOAM GCP image for your OpenFOAM jobs, just make sure at the top of your batch file, you run these 2 commands to source openmpi.sh and openfoam.sh. This makes sure that you have the correct compiler, GCC9, and the correct MPI, which is OpenMPI version 4, in your path. The openfoam.sh file, of course, brings all the OpenFOAM executables and binaries and other script tools into your path so you can run your OpenFOAM jobs. I do a sanity check down below just to make sure we have the correct GCC version in there. And then from here on, essentially, is where we start the OpenFOAM work. So what I'm doing right here is copying the row simple foam tutorial, the aerofoil NACA 012 simulation. So this is, remember, if you're familiar with the tutorials, this is a compressible flow past an airfoil. It's essentially 2D. So not a huge job, but it's a really good way to demonstrate to you guys how all this kind of works. All right, so once we copy that directory into our home directory, we navigate into it, and then I do actually insert a domain decomposition file, this decompose partict, which is just a foam file that allows you to do domain decomposition so you can distribute your workloads across MPI ranks. So if you have if this ends up being useful for your workflow, I'm hoping that's what you can get out of here. The neat thing I've done here is in the number of subdomains, we basically script that to use Slurm ntask, which is an environment variable you get for free when you run your jobs underneath SBatch. And remember, up above, we set ntask as 8. So essentially, we're scripting this to set up to have domain decomposition for 8 MPI ranks. Okay. Down below that, we just really go through the pretty standard OpenFOAM sort of workflow here, where we're basically doing mesh generation. We copy in our geometry files so we can describe the shape of this airfoil, the shape of the boundaries, since this airfoil is kind of nested inside of the domain. Go through block mesh and extrude mesh to make our 3D mesh, and then we use decompose par to do domain decomposition so that we can distribute that work across 8 MPI ranks. Now down below we have MPI run, and we pass into the -NP flag, so this stands for the number of processes, which of course it's synonymous with the number of MPI ranks here. And we're just going to run row simple foam in parallel, so you got to pass that parallel flag into it. And then at the very end we call reconstruct par to essentially just stitch all that output together to make a nice clean database of fluid flow simulation output. So let's take a look at how that job's doing. If I run SQ, you can see we're in a running state. It's been running for about 1.5 minutes. And if I list in my home directory, you can see now I've got openfoam2.log in there, and now I've got this aerofoil folder in there. Let's take a look at what's going on in that OpenFOAM log just to see where we're at. Okay, it looks like we actually already finished the simulation, which is great. So finalizing that parallel run, and then it's going to start doing that reconstruct par. So let's go ahead and get out of that, and let's take a look underneath the aerofoil directory. And there you go. We've got all of our output for this fluid flow simulation. So I hope this kind of gave you a really quick introduction to how to get started with OpenFOAM. Feel free to use that repository to help get yourself started with running OpenFOAM on GCP. Next week, what we're going to be looking at is how to run how to run ParaView on Google Cloud. And essentially what I want to show you how to do is use your ParaView client on your local workstation to connect to ParaView server running in parallel on this auto-scaling HPC cluster. And essentially, it's a pretty neat way to do this rather than using like X11 forwarding to do those graphics. This is actually a pretty clean way to basically send off all these large rendering and post-processing workloads onto the cloud and just have the final results presented on your local screen. Thanks again for joining. I hope you found this useful, and we'll catch you next time.